All right, hey there, sixth graders. Since I am not here for the afternoon, I want to go through and tell you what you're going to do in this video, as well as give you some notes as we go through this. So let's just kind of start with the overview of what I want you to accomplish today when I'm not here. So first thing is going to be if you have not finished Earth's Interior worksheet, that digital worksheet that you were using the red books in the back of the classroom. That has to be your number one priority. I am putting a hard deadline on that by tomorrow. I'm going to go through, just check to see if they're done tomorrow, mark them late if they're not finished. So that's the first priority, is going through that Earth's Interior worksheet. If you're not sure if you're done with it, or you know you need to finish it, you find it down here. If you're looking here, I'm going on Google Classroom, back to class directions on Wednesday, 8/28. Last Wednesday is when it was first assigned to you, when I posted it, okay? 8/28. So there it is, Earth's Interior worksheet, Wednesday, 8/28. If you need to see if you're done, or if you know you're not done, you need to finish it, okay? That's priority one. Hard deadline tomorrow. Okay, number two. In a moment here, I'm going to go through 2 slides of notes with you. And so you guys will type in the notes and listen to as I go through and explain the notes in those 2 slides. After you're done with the notes, then you are going to work on an Ed puzzle. The Ed puzzle goes through some lab safety, some basic lab safety that's important for us to know. And then lastly is a Kahoot. The Kahoot is not for a grade. The Kahoot is a preview of some of the important concepts you need to know for this unit. And so you might be able to get some of them right. You might even know some of the answers, because we have talked about some things with Layers of the Earth, and we watched Birth of the Earth. So you might be able to get some of them right. But I don't want you to get nervous in terms of an accuracy on that Kahoot. It's a preview. I want you to see kind of like the roadmap of what are some of the things that I need to know by the time this unit is over. All right, so that's kind of the layout. At this point, if you need to check to see if your Earth's Interior worksheet is done, or you know you need to work on it, pause this video, get that all taken care of, then come back to it to be able to continue with your notes. All right, at this point, if you're on the video here, that means you are done with Earth's Interior worksheet, that digital worksheet from last Wednesday, and you're going to take some notes. So if you need to, like it shows here on Google Classroom here, go down to Class Notes, Layers of the Earth. Open up that doc. Here is where we left off. So we talked how if you just had to answer with one word of why there are layers of the Earth, the answer is density. And we know that when the Earth formed, it melted, and those liquids separated by their density. The least dense went to the top, which is the crust. The most dense, the core, went to the center of the Earth. We also know that it's separated into 3 main layers, the crust, the mantle, and the core, and we're going to break down those layers one by one, and today we'll start with the crust. But before we even get to that, we need to talk a little bit about what seismic waves are, because seismic waves are the key for us knowing and how scientists have figured out over the years what is beneath us. We've never been able to dig past the crust. So how do we know about the mantle? How do we know about outer core and inner core and all of these things? Well, one of the main reasons of why we know are seismic waves. So what are seismic waves? Seismic waves are produced when there's earthquakes, and they travel through the Earth. There are a couple different types of seismic waves. The ones that are up on the surface are called surface waves, and those would be the ones, if you've ever been in an earthquake, those are the ones that cause the shaking and are the ones that we think of with earthquake, because that's what we would feel. But there are other seismic waves, energy that travels beneath the surface, and those are called body waves. And those are the ones that we're going to be worried about mostly here in this unit, because those body waves, the waves, seismic waves that travel beneath the surface, are the ones that give us clues about differences in the Earth's interior. How? Well, we record these waves. We record them at things called seismic stations, and there's hundreds, if not thousands of them throughout the world. And the really crazy thing is that these instruments, these seismograms, are so sensitive that they can record earthquake waves from the complete opposite side of the earth. And so by studying these waves when an earthquake happens, we've learned lots about the earth because these waves have had to travel from one side of the planet to the other, all beneath the ground. So what do we see? Well, like you just typed in there, you had to type in the words speed and path. The speed of the waves does not stay consistent as it travels through Earth's interior. It speeds up or slows down. The path of the waves does not stay consistent as it goes from one side of the Earth to the other. In fact, some of those body waves, the seismic waves beneath the ground, don't even make it to the other side. So take a look at this picture here. Let me move myself. Okay, in this picture, this is just showing the path of P and S waves. Okay, now the P waves here, as you can see, travel as they go through, right? You have these P waves, these yellow ones, go through. I guess I should point out the epicenter here, that means the center of the earthquake, the origination of the earthquake. So the waves come out, and when they get to this area right here, we see a change in the path. Notice there's no more black arrows that go through. The black arrows, if you look down here, are the S waves. The S waves stop when it gets to this area of Earth's interior. Well, that gave us all the info that scientists needed to determine that the outer core must not be solid because the S waves cannot travel through it. And because they don't travel through it, that shows us that it's no longer solid. So that led us to know that the outer core is liquid, the only layer that is liquid. Notice the change of these P waves too. They bend and change. That's some of their path as well as their speed. That bending and refracting of those waves shows that their speed is changing. And the reason the speed changes is because as it travels through different material, it can speed up or slow down based on the density of the material. The more dense it is, the faster the waves travel. And if that doesn't make sense of why, we'll talk about it later with a demonstration that I'll do with you guys when we go further into what P and S waves are, primary and secondary waves, and how to read a seismogram. Okay, so let's go through one layer here, the crust. The crust is the top, outermost layer. It's made of rock, and it's the outer skin of the Earth, the shell of the Earth. The scientist in the Birth of the Earth video referred to it as like a scab, the scabbing over as the Earth cooled. The outside cooled first because it was in contact with the freezing cold vacuum of space. And so that crust formed first, and it's rock. Now, what is probably new material to you guys that you didn't learn if you learned things about the layers of the Earth in elementary school is that there's actually two different types of crust, and you're going to need to know these. The first one's called continental crust. And if you're looking at the diagram here, you can see the continental crust is like that brown or tan color. And it's called continental crust because it's below the continents. It's below land. A couple things about the continental crust when we compare it to the other type of crust. It's thicker than the other type, but it's less dense than the other type because it's made out of a different type of rock. And it's older. So thicker, less dense, and older. Continental crust, one of the types, and that's the land crust, the rock that's beneath the land. The other type of crust is the crust that's under the water, under the oceans. You'll never guess what they call it. Oceanic crust. You're so smart. The oceanic crust is literally the opposite of the continental. It's thinner, more dense, and younger. Now, if that doesn't make sense, like, wait, how can it be thinner, but yet it's more dense? Because doesn't density have to do with heavy and weight? Well, partially. And we'll get to that more as we study density here. But think more so of the fact that this rock has been squished, compressed. And so because it's been squeezed, there's more matter in that space, and so that's what makes it more dense. Where the continental crust is kind of spread out over a bigger area, the weight is spread out over a bigger area, so it's less dense. So continental crust, thicker but less dense. Oceanic crust, thinner but more dense. All right, we'll talk about what causes a difference in the age of these crusts too. Ocean crust is being remade and recycled way more often than continental crust, and that's kind of the gist of why it's younger. But we'll get to that more as we get into our next unit. For now, you just need to know the two types of crust, continental and oceanic, and you need to know these little facts about them as we move forward too. Okay, that's all we're going to do for the notes. And so going back to Google Classroom, going back to today, that leaves you with two more things to try to get done before class ends. One is the Edpuzzle that's going through lab safety, just kind of general lab safety stuff, which is important to know. And then a Kahoot, which is the preview. Again, it's not for a grade. It's to show you some of the important facts that you're going to need to know about the layers of the Earth. So I want you to complete it, but I don't want you to freak out about the grade. All right? All right. Get your work done. If you have questions, please talk to the sub. Be flexible as you go through today. Have a great day.